So the SASEBO-W board is a side channel attack standard evaluation board. And this is a very nice board that you can use for testing with smart cards. So we have up in the top right corner a smart card reader. So here I'll plug a card that's been pre-programmed with some AES code into the board. You can see there, and there's these jumpers that let you select a 1 ohm resistor, so we can measure the current across this 1 ohm resistor. You can see the resistor right there. And you have these SMA connectors, which you can connect in an oscilloscope or other measuring device. So how to make this even better? What I'm going to show is I have my OpenADC, which is a ADC board, and it can be configured to easily work with the FPGA on this board. So we can just plug it right onto the I/O headers here, and all of the control signals will come from the FPGA that's already mounted on this board. And all I'm going to do is connect it across the shunt measurement device here. So with this, the entire system, the entire side channel analysis platform, can just be connected to a computer using a single USB cable, and it's all very convenient. So once you have it plugged in, how do you actually go about doing this? There's some various firmware I've developed and software as well. So we'll have an example of that. So here I'm connected to the board, and what I'm going to do is set up the 2 serial ports, one for the ADC, one for the smart card, set up something to trigger, set up some configuration for how many samples to take. And once we click it, we can see some of the LEDs will go to indicate activity. And we can see a trace there. The trace doesn't have much to it, so I'm going to increase the gain and click capture gain, so we can increase the gain a little more, and we can see this is actually amplifying the signal. So the analog front end of the OpenADC is amplifying the signal to get us something that starts to look a lot more like a power trace. Now the other cool thing the OpenADC lets you do is synchronize perfectly to the device clock. So here I'm selecting the external clock, and I click sample again, and whoa, we get way more traces. So in those same number of samples, we've made more efficient and got more data. So I can keep pinning capture here, and you can see this is, in fact, you're viewing the various rounds of the AES occurring on the smart card. So you can sort of zoom around a little here. And the other feature you have is this phase adjust. So you're selecting when the sample is taken. So you can play around a little with this to see the effect of when in the clock cycle you take the sample. Right now, the OpenADC samples 4 times for every smart card clock cycle. And you can see sort of if I change this, how it affects the results. So this video is just showing the capture, which as you can see is very easy to do. And sort of this whole platform is a great way to work with smart card power analysis. You can check out some more information on newae.com if you're interested. And thanks for watching.